video. But let's take a look at the review of 10.5 and 10.5 to 10.8. So let's start with the hardest problem that I think many of you guys have problem with in terms of the expected value. We did this in 10.6. If we have an expected value, if we have a ticket, we have a dice or something like that. So let's take a look at this question. They say Omar have a deck of card, deck of card number 1 through 10. He is playing this game of chance. This game is this Omar choose one card from a deck at random. So again, let's say we have 10 cards in this, we shuffle them up. He will win the amount of money equal to the value of a card if is a odd number card is draw. So basically, he only win if he draw out a card and that card is a odd number. If he draw out an even number, he will lose, right? He will lose $6 if it's the even card is draw. So again, if he draw out a 1, he will win $1. If he draw out a 3, he win $3. If he draw out a 5, he win $5. If he draw out a 7, he win $7. If he draw out a 9, he win $9. Right? So that's the game of the rule of this game is that, right? If he draw out an odd, he will win the amount corresponding to that number. If he draw out an even number, he will lose. So if you see part A, they ask you find the expected value and what is Omar expectation in the long run, right? What is he expected in the long run? So looking at this thing here, if you remember to find the expected value, this is what you guys need to have. This is the table that you want to construct, or this is the table I asked you guys to construct. Is we want to construct the amount of winning and the amount of loss, right? And as I mentioned, he will win $1 if he draw out a 1. He win $3 if he draw out a 3, so on and so forth. And if he draw out an even number, which is a 2, a 4, a 6, an 8, and a 10, if he draw those items out, he will lose $6. And because of the loss, we use at a negative, right? So in this item, this is what we have: 1, 3, 5, 7, 9, and the -6, which is the loss. And once you find the amount, once you identify what is the amount you win or loss, you need to know what is the probability of that amount, right? How can you win $1? Well, how many cards contain number 1? Well, there's only one card out of the total, which is 1 out of 10. How many cards contain number 3? We have 1 out of 10. How many cards contain number 5? There's 1 card out of 10. How many cards contain number 7? As you can see, each of this thing here, there's 1 card corresponding to this number. And there are 5 cards that is even: the 2, the 4, the 6, 8, and the 10. There are 5 cards, and that's why there's 5 out of 10. So all I did was the probability is the item we have over the total, and this is the decimal corresponding to this fraction. And now the third item is all we need to do is take the first column, multiply to the second, which is the $1 multiplied to 0.41, $3 multiplied to 0.1, and so on and so forth. So this is the table that you want to construct. You want to have the amount, the probability, and then the multiplication of the two. And again, we're still not done, because to find the expected value, all you do is you take each of the results and you add them up. You take the 0.1, add with the 0.3, add with the 0.5, add with 0.7, add with 0.9, and then add with a -3. So if you add them up, you will see that we have a negative point. We have a negative 0.5. Or in this case, we are losing, because it's a negative, we are losing 50 cents, right? So again, what is the expected value? The expected value is a negative 0.50. So because it's a negative, we can see that in the long run, we expect to lose, Omar expect to lose, and how much does he lose on the dollar? He will lose 50 cents on a dollar. So for each dollar that he spent, he will lose 50 cents, okay? So that's the idea of this expected value. We went over this thing here, and again, this is what you need to do, is you want to construct this table. And to construct this table, you have to identify what is the winning and what is the losing. Okay. And again, same idea go. Let's take a look at another problem, and then I take your question on hopefully the second one. You will see the consistency of this thing. So same idea go. And again, I know if you have a question, hold on a bit. Let's go over this second question, and then we see if it's clear or is more confusing after this one. So Jenny is playing the game of chance. Again, different person plays different game in which she will roll a number cube with the side have a number 1 to number 6. So we have a dice, right? This cube or this dice have 6-sided, contain number 1, number 2, number 3, number 4. So this thing will roll at random. So this game, in this game, this is what we have. Jenna will roll a number cube 1 time. So she roll this die 1 time. She will win $1 if it's roll on number 1. She will win $2 if it's roll on number 2, or if it's land on number 2. And she will win $3 if it's land on number 4. And she will lose $1 if it's land on number 4 or 5 or 6. So if it's land on 4, she loses. Number 5, she loses. Number 6, she loses, right? So in this case, they, like, unlike the previous problem, this one here, they list out how much she win and how she can win. So she will win $1, she will win $2, she will win $3. And if she lost, she will lose, right? If she lose, her loss will be just $1. So everybody see the number that we win and the number of the loss here, right? The gain and the loss. So looking at this thing here, to find the probability, again, how many number 1 are there? There is only one number 1 out of 6-sided. That's why we have 1 over 6. There's only one number 2 out of 6-sided. That's why we have 1 out of 6. There are only one number 3 out of 6-sided. That's why we have number 6. And now, why do I have 3? Because there is one number 4, one number 5, one number 6. There are 3 chances that she will lose, right? Which is 3 over 6, which is 0.5. So if you look at this thing here, this is the amount of winning and this is the amount of loss. This is the probability for each of the winning and the loss. And once we have this thing here, we need to multiply the first to the second, the first to the second, first to the second. We just multiply them up. And once we have this thing here, we need to add them all together. And if you add them all together, this is what you have. You have a positive 0.50. Meaning if it's a positive, unlike the previous one, if the result is positive, we will win 50 cents, right? 50 cents for every dollar we spend, we will win 50 cents, which is in the long run, Janet will win 50 cents on a dollar, 50 cents per dollar, right? So again, 0.50 of the dollar, which is 50 cents per roll. So every time she roll in long run, she will expect to win 50 cents. Okay, so that's the idea of this expected value. And if you did the homework, you probably saw some of this thing here already. So let me ask you guys question of this item here, what you guys need and how we get to the answer. All right, if you don't have question, let's do one more try, right? Same idea, right? Same idea. It's just this game of chances, you know, and you know, casino and stuff like that. When they do this thing here, they will always want to have a positive and you have a negative, because in the long way you will lose, right? In the long run you will lose. But let's take a look at this game. How does this game play, right? Ravi is playing the game of chance. He will throw the dog into this dog ball. And this dog ball have 7-sided. Like if you go to any fair or raffle, you see this thing here have equal side number 1 to 8. The dog land on any number at random, right? So this game, you would throw a dog. He will win $1 if it's land on the slide contain number 1. He will win $3 if it's land on the slide number 2. He will win $5 if it's land on the slide number 3. He will win $8 if it's land on number 4, and $10 if it's land on number 5. he will lose $9 if the dog is land on number 6, number 7, and number 8. So again, imagine that we have this thing here and they spin, not stay at the same location, right? And again, you just throw the dog, and if it's land on any of this number, this is the price that you win. So if you dissect this thing here, we can win $1, we can win $3, we can win $5, we can win $8, we can win $10. Okay, and again, if we lose, we will lose $9, right? So if you look at this thing here, how many number 1 do we have? We have 1 out of 8, 1 out of 8, 1 out of 8, 1 out of 8 chance, 1 out of 8 chance winning all those. And again, number 6, number 7, number 8, which is we have 3 out of 8 chance that we will lose. So if that's the probability, is what we have over the total. And once you have the amount, once you have the probability, what do? We just multiply them together. And in the end, after you multiply them, you have to add them up. Again, you add them up. If it's negative, you have to use as a negative. If you add this thing up, as you can see, this is a fair game. The fair price, right? Why? Because you have the expected value of 0, meaning everybody break even, right? You break even, everybody break even, which is in the long run, you will see that Ravi will break even. He might win some, he might lose some, and in average, on the average, he will be breaking even, right? He will keep his money, and the fair will keep their money. They won't pay anything in terms of that. So this is a fair game. Okay, so again, if it's come out to 0, it's a fair game. Nobody win anything. If it's come out to be a negative, you will expect to lose. If it's come out to be a positive, you expect to win. Okay, so looking at this thing here, question with this expected value. And I think we did this expected value before hurricane. So again, you can look over the old video in more detail of the item. Now, let's take a look at the next item. If you don't have the expected value question, let's take a look at this question. So they will give you some information like this, and they say 3 shopper from a survey is select at random, 1 at a time without replacement. And hopefully you guys see, oh, Mr. Trent, that's trick or something, right? Without replacement. Meaning again, we do multiple times, right? How many people are we select? How many shopper are we select? We select 3 shopper, and we replace them back? And in this case, we do not replace them. And hopefully you remember, if we don't replace them, it's a dependent event. And if it's a dependent event, this is what we need to do: is we need to multiply the first shopper, multiply to the second shopper, but we have to decrease them because one of them is gone, right? So looking at this item here, this is what they ask you: is find the probability of an electronic shopper and the electronic shopper and the clothing shopper, right? So the first 2 shopper purchased electronic, and the third person purchased clothing. So again, just instead of write electronic, I put E for electronic, and C for a clothing. So because of this with and, right, we want the first person, we want the second person, we want the third person. So what is the probability of electronic? Do you agree that we have 30 electronic out of the total of 90, right? So do you agree that the first person I select, the probability of electronic is I have 30 electronic out of the total of 90. And now I get that person. I do not replace him back or her back. Now I go in second time. The second time, because I don't replace them, everybody see that I have 29 over 89 because 1 less. And now the third person, I want the clothing, which is the clothing, I have 32 out of, there's no longer 89 because there's 1 less, which is because we do not replace them. We have 1 less, right? The criteria might be different. The reason why we have 32 is because of the clothing. The clothing is 32, so it's not 28, right? because of the clothing is 32, that's why I'm using the 32 here. So if you multiply this item, again, you just take top, bottom, top, bottom, and then you divide, you will get that the decimal, they ask you for 3 decimal place, which is 0.039. So this thing here we did earlier the last time too, because it's without replacement. We know that without replacement is dependent because one depend on the other, and because it's dependent, we need to deduct. And again, like I say, in words, your denominator have to be one less. How many every time you take it, we have one less. Okay. So again, looking at this thing here, question on how I have 30 over 90, 29 over 89, and 32 over 88. And again, similarly, right? They ask you very much identical, right? Whatever the story is, this one here, the volunteer, right? The college student volunteer, and they volunteer as a nursing home, as a library, as a tutor center, at the pet shelter. So this is the number of students who volunteer at nursing and so on and so forth, right? So if you add all of this thing here, the total is 50 students. So in this survey, in this study, there are 50 volunteers, and this is the distribution of each one. And now if you look at this thing here, they ask you the same thing. 3 students is selected, right? 3 students is selected at random, 1 at a time, without replacement. Again, we know that we don't put that person back. What is the probability of none of the 3? None of the 3 volunteer at the tutor center. So we don't want a tutor center, right? We basically, as you can see, we don't want the tutor center. So do you agree that the nursing home is not a tutor center, library is not a tutor center, and the pet shelter is not a tutor center? So basically, whoever the tutor center is, I don't want that, because none of the 3. I don't want any of the 3 as a tutor center. So do you agree that anything else except tutor center is not a tutor center? So in the center of this thing here, this is what we have is we want to find the probability of none of the 3 is at the tutor center. So to find that, do you agree that this 11, this 13, and this 18, if I add them together, I will have 42 students out of the 50 students volunteer that is not at the tutor center, because there are 8 at the tutor center, the leftover will be 42, right? Or you take the 11 plus the 13 plus this. So the first volunteer that I picked, do you agree that I have 42? 42, none of this 42 is at the tutor center because they volunteer as a nursing home, they volunteer at the library, or they volunteer at the pet center. So 42 over 50. And if I go in the second time, do you agree that now I have 1 less because I don't have 42 anymore? I have only 41 out of 49. And if I go in one more time, I have 40 out of 48 because again, all 3 of them are not from the tutor center. Basically, I subtract the tutor center out. I have the leftover, which is 42 over 50. That's the first student that is not a tutor center. 41 out of 49, that's the second student that is not a tutor center, and 40 out of 48, which is the third student that is not in the tutor center. So again, this thing here, that's what we need to do is we multiply. And again, like I mentioned in the other lecture, if you do multiple times, you would think in terms of multiply. So in terms of this thing here, we do multiple times. So that's why we multiply. And if you multiply the numerator and then multiply the denominator and divide it 2, you will get 0.586. So question would A or question would B in this slide here. Question with this 2 problem. Very similar to what we went over in class. Instead of give you a horizontal chart or table, this one here, they give you the vertical. All right. one thing is I did not go over a lot in terms of this definition here, this definition of independent. So one thing they tell you to do is, in order to know if independent, and I took this straight out from your Alex item, is basically tell you that in order to know if it's independent, the probability of A and B, if this item is equal to the multiplication of the individual, if they multiply, if probability of A multiplied to probability of B is equal to this item, then they are independent. Or if the probability of A given B, if this conditional probability is equal to this individual probability, if this is also the case, then they are independent. Or vice versa, if this probability B given A is equal to this item, they are independent, basically, again, meaning they do not affect each other. Okay, so this is the three criteria in order to be independent. If none of these three criteria met, then they are not independent, therefore they are dependent. Okay, so basically this is the three criteria that you want to verify. If the multiplication of the two is equal to the n item, then they are independent. If the A given B is equal to the A, then they are independent. If the B given A is equal to B, then they are independent. Okay, so those, keep in mind of those three. So looking at this thing here, they ask you, or they give you this item, and again, if you guys confused, this is what they ask you is, given A, they give you this item P of A, P of B, and this item here BA, and they ask you, given this criteria, is it dependent or independent, right? So how do we determine this? Well, what do they give us? Do you agree that they give us this item here? This is the key item that they give us, is this item right here. They give us the probability of B given A. And if you remember on the previous slide, right? If you remember on the previous slide, this is what they tell you is B given A is have to be equal to B. If this is happened, then they are independent. Or again, I type it here. This is what we have is B given A got to be, have to be equal to B. Meaning we don't care about this one here, ladies and gentlemen. And this is probably, they give you extra thing that you need. Basically, we don't care about this one because they ask you, this is what we need to verify. They give you probably B given A. If this item is equal to this item, then they are independent. If they are not equal, then they are dependent. So if you look at this two item we have here, if you look at this two item, B given A, is this number equal to this number? And clearly enough, as you can see, 1/5 is not equal to 1/9. And if they are not equal, we say that they are dependent. And that's the idea of this thing here, is you have to choose either independent or dependent. And again, same thing go. And this is what you have to ask yourself is, what do you zone out? What do you block out, right? So if they give you this thing here, if they give you the A given B, if they give you A given B, then you want to verify if this item is equal to this item. And that's the three criteria, which is A given B, is that equal to probability of A? And in this case, they are not equal. If they are not equal, we say that they are dependent. That's what you need to make a adjustment that you have, right? And again, same thing go with this item here. What are we zone out, right? They give you one extra information. Well, not really extra, right? They give you this item that we need to zone out, right? We need to verify this item here, the last item. That's what we need to verify. Is this item equal to probability of A? Because that's my definition. If they are equal, and in this case, do you agree that they are equal? All right, 1/5, 1/5. They are equal, and because they are equal, we say that they are independent. And that's why, again, this is dependent. This is dependent, and this is independent because they are equal. And that's all you need to do for this particular problem. Okay. And again, this one here a little bit different because they are not give us a conditional probability, right? They're not given this B/A or A/B, right? They ask us or they give us A mod and B. And A and B, this is what you have is the probability of A and B is equal to probability of A multiplied to probability of B. So in order to know if they are independent, you need to take this item. You need to take this item 1/5, multiply to this item 1/2. If you take that two item multiply, is that equal to 1/10? And hopefully you guys see that 1/2 times 1/5 is equal to 1/10, right? If you, this is what you need to type in your calculator is 1 divided by 5 multiplied to 1 divided by 2. And if you multiply that out, your calculator should give you 1/10. If it's not, you need a new calculator. Just kidding. Again, this here 1/2 times 1/5. If you multiply this, this is 1/10, and 1/10 is equal to this, and that justify our item. And if it's justify your item, then we say that these two items, A and B, they are independent. Okay, and that's the idea of this question. If you look at this thing here, or if you did this question and you kind of don't understand why or how to determine if it's independent or dependent, is basically they ask you to look at this criteria. Looking at this item here, if this is work out, if this two item equal, they are independent. If this two item equal, they are independent, or if this two item are equal, they are independent. Okay. Question with this particular problem, ladies and gentlemen. And similarly, one more type of this, same idea, go, right? Same idea, they give you this item, and again, this is what we want to verify, or this is what they ask you to do is verify this item, verify this item. We're using this item to verify if A and B are independent. And this is what you need to ask yourself, or this is what I tell my student, if it's /B/A, if it's B/A, we don't care about the A. If it's A/B, we don't care about B. If it's A/B, we don't care about B. If B/A, we don't care about an A. No, that's what you need to ask yourself, or that's what you need to remember is the conditional probability of B given A is equal to B. If the probability of B given A is already happened and B is equal to this item, then they are independent. If and again, looking at this thing here, you can see clearly this item and this item, they are not the same. 1/6 and 1/2 are not the same. And if they are not the same, they are dependent. And vice versa, same thing go, right? If A given B is equal to probability of A. So if these two items are the same, then they are independent. In this case, they are not the same. If they are not the same, then they are dependent, right? And again, you can see that these two items, C and D, this two item, if you zone out, and that's the idea, right? That's the idea is you have to know what to zone out. And the difference between this problem versus the previous one is they have the B and A, right? If they have the B and A, for this particular problem here, let's say that, let's take a look at this problem and let me change it, right? Let's not worry about this one here. Let's say if I ask you, or I give you this item, I give you probability of A and B is equal to 1/16, right? If I give you this item and I ask you for D, for this particular information here, for this information, can you verify, for this information, can you verify if you have an independent event or a dependent event, right? So in order to verify this item, given just this item right here, to verify this thing here, we need to know, we need to see if 1/9 multiplied to 1/2 If you multiply this thing here, 1 times 1 is 1, 2 times 9 is 18. So you can see that this item, if you multiply them, is 1 over 18, and 1 over 18 is not equal to that, right? This item and this item are not the same. And if it's not the same, then we say that they are dependent. If they are the same, then we say that they are independent. Okay, that's the idea, is the multiplication is the same as the and, then they are independent. Okay, so again, to go back to this thing here, question, ladies and gentlemen, question with how to determine if they are independent versus dependent based on this criteria. Like I say, I did not go over this during lecture because I just basically emphasize the definition. So now they're using this definition to the extent, right? So we did this in our lecture, but I did not do it this way, this type of setting. So let's take a look at this item here. Again, one thing is a lot of information will given to you guys, and sometimes it's overwhelming to know what you need and what you don't need, right? Sometimes it's easier to ask yourself, what are they asking me, right? This is what they ask you is, right? This is what they, in short, this is what they ask you. They ask you P of student, P of t-shirt and student, and P of t-shirt given a student. So this is what you have to ask yourself is, again, we only select one person, right? So this and right here is not the t-shirt and then the student. This and right here is the intersection of the two. So they ask you to find the probability. If you read this thing here, ladies and gentlemen, this is basically tell you for A, they ask you find the probability of a student. If I select one person, find a probability of that is a student, right? So again, how do I find the probability of a student? Well, to find the probability of a student, this is what I need to do is I need to know how many students, the number of students over divided by the total number of everyone, right? The total number of people that I have in this study. So looking at this thing here, do you agree that the number of students is this? Doesn't matter t-shirt or sweatshirt, I have 20 of them, and the total people in my study is 50, right? So in this case here, to find the probability of a student, all I need to do is, again, I have 20 student, 12 plus 8 over 50, and if I divide that, because they asked me to write in decimal, I divide that will give me 0.4. That's the number of students. And this thing here, they ask you find, if we select one person, find the probability that that person bought a t-shirt and a student. So how many people bought a t-shirt who is a student? Again, there is only 8 of them bought a t-shirt who is a student, right? So again, how many of them, which is in this case, we have 8 over the total, which is 8 over 50. And 8 over 50 will give me 0.16. Okay, so again, the probability of student, how many students I have 20 students over 50 total. The probability of student and t-shirt, or t-shirt and student, meaning they are a student who bought t-shirt, which is 8 of them, who is a student, and they bought t-shirt over the total, which is 50. And now the slash, right? This item right here, if you remember this notation, I keep on mentioning, and you will see a lot, this slash, this vertical line is the conditional probability. And if you forgot the conditional probability is equal to the probability of t-shirt and student divided by the probability of student by themselves. Okay, so if you're looking at this thing here, they ask you find the probability of is basically find the probability of a find the probability of a person who bought a t-shirt given that that person is a student. Okay, so if you remember, I told you anything after the word given is your denominator, or in this case, again, the purpose of them giving you this problem is this, ladies and gentlemen. All you need to do is to find part C. To find part C, all you need to do is take the t-shirt and a student, which is 0.16, divided by the new denominator, which is the denominator is a student, which is 0.4. Basically, take part B divided by part A, and that will give you the same answer, which is 0.4. Okay. Or if you remember, we did this in class. I did this in class. I told you, if I ask you this question, find the probability of a t-shirt buyer given that person is a student, right? So if they ask you, this is the same question as they ask you over there. Find the probability of a t-shirt buyer given that that person is a student. And to find a probability, this is what you have is how many t-shirt and student. As you can see, this is how many we have, which is those are the t-shirt and a student. And what is after the word given? Well, after the word given is your new denominator. And if you remember, how many students do we have? We no longer compare to the 50 people. We only compare to the student, which in this case, if you remember, let me change the color here. If you remember, this is what I told you is your student is your new denominator. And your new denominator, how many students I have? My student is I have 20 students. Of those 20 students, how many of them bought t-shirt? Well, of that 20 students, there are 8 of them. And if you press this in your calculator, you still get 0.4. Regardless of what you do, it's just, again, the reason why I show you this way is the purpose of this problem is they tell you take part B, divide by part A. And that's what your conditional probability is the intersection of the two divided by the individual item, right? And again, 8, which is the intersection, divided by the total of the given item, okay? So again, we will go over this a little bit, but based on this item here, based on this item, based on this particular problem, this is what you want to do is do part A, do part B, and part C is take the part B, divide by part A. And they lead you to it. They lead you to that item, okay? And again, let's try one more. Let's try this item here. So we have a sport and we have no sport. We have a male, we have female. We know the total is 80 student total, right? That's the total they give us. If not, you add this item, that's what you have. So they ask you, what is the probability of support? So again, this is my support. And if I add this together, do you agree that 12 plus 28, the total is 40? So there are 40 students play sport. There are 40 students play sport, right? So what is the probability of support? Do you see that all I have is 40 play sport divided by the total, which is 80, and that will give me 0.5, right? 50%, 50-50. 50 people play doesn't play sport, 50 people play sport. And now for part B, they ask us the female who plays sport. So how many female play sport? Well, the female play sport is this item here. So what do? Well, we just take the female who plays sport, which is the 28, divided by the total, which is 80. And what do we have? This is the 0.35. Again, the N is the intersection of the two all over the total. And this item right here, this item is basically tell you take this part B divided by part A. And if you divide them, again, this thing here, you can see that the answer or this is what we have is different answer from prior, so that you don't get that mistake. Okay, but again, if you look at this item and you say, oh, Mr. Tran, can I do the same thing that you did before, which is take 28 divided by 40? If you take 28 divided by 40, you will see that it's equal to the same. It's equal to 0.4. So again, in this item here, this is what they want you to do, or they want you to see. They kind of lead you from port A to port B to port C. So again, question here, ladies and gentlemen, question with this particular problem. Question of how to find port A, how to find port B, and port C is the combination of B and A. Is the conditional probability. So I think this is where your problem, this is the majority of the problem that you might encounter. Instead of give you the data, the raw data like that, they give you something like this. And I think this is where many of you got problem with the item. But again, forget about the data, right? Forget about the data. Let's read A and B first. Let's read A and B. And this is what, for me, this is what I do is I read a question. I read, ask me what they ask, ask yourself, what are they ask me to do? And if you read this item, they ask you to find the probability, which most of this thing, they will ask you to find the probability. Find the probability that a senior citizen suffer anxiety given, oh, that's the keyword. If you remember my lecture last time, the word given is a keyword because this tells me that this is a conditional probability. Given what happened, given that he or she have a sleep disorder. And again, if you look down here for B, they say given, oh, that's the word, the keyword, given that a senior citizen suffer anxiety from anxiety, what is the probability he or she suffer from sleep disorder? So if you remember, right, if you remember, I told you guys that anything after the word given is your new denominator. Or if you look at this item, if you look at the previous item, this right here, I give you, or not I give you, but I ask you that given, right? And given, and anything after the word given, this is what they tell you is find the probability of a female given that she plays sport. And anything after the word given, as you can see, the word sport, given, this is my new denominator. Everybody see that? My new denominator is anything followed by the word given. So this thing here, find the probability of female given that she plays sport. So whatever for the word given is my new denominator, and that is what I have. My new denominator is 0.5. And now the intersection of the two, the and, is my numerator, which is the and is right here, 0.5. So the reason why I show you this problem is let's take a look at the information that they give us, right? What information do they give us? Now, we know that this is a conditional probability. So what information do they give us? Well, they give us 91% of a senior suffer from sleep disorder. So sleep disorder, 91%. Anxiety, 8%. Furthermore, moreover, what happened? 5% of both suffer both items, right? So looking at this thing here, let's dissect this information. Do you agree that the percentage, the probability of sleeping disorder, the probability of sleeping disorder is 0.91? Basically, I take the percentage, I move the decimal place, 90.91, which is 91%, that is the probability of the senior citizen that have a sleep disorder. And if the probability of 0.08, those are the senior citizens who have anxiety. And because they say both, basically is sleep disorder and anxiety, which is 0.05. So again, all I did was I took the percentage and I convert that to decimal. And to go back to what I mentioned, to the previous problem, what followed by the word given? do you agree that followed by the word given in this first item is slip disorder? So all you need to do, or if you look at this item, if you were to write it out, this is what you have is probability of anxiety given slip disorder. Again, the vertical line, that vertical line is your conditional probability, which is given. And if you remember, all we do is what is after that given the slip disorder. So the slip disorder will be your new denominator. Your new denominator, which is 0.05, and the combination of the two, which is the n, which is 0.05. And if you divide this thing here, you will get 0.05. I did not put the answer on the side, but this is the answer we have right here. Okay, so the idea of this thing here, and again, they purposely give you, they change the word given, but everybody see that right here, given that they suffer anxiety, meaning the probability of sleeping disorder given anxiety. What is the probability that he or she suffer from sleep disorder given that he or she suffer from anxiety? Which is, again, this is what we have. And if you look at this item, this is what, the goal or the connection between the two is anything after the word given is your new denominator. My new denominator here is 0.08, and the combination, the n, is the numerator. And that's what we have. And in this sense, the answer for this item right here is, if you divide them out, this is what you should have. If you take 0.05 divided by 0.08, you should have 0.63. Okay, so if you have this problem, if they give you this problem, this is what you ask yourself is, identify what percentage, convert the percentage to decimal. And again, what is the percentage? They will always give you one item, another item, and the connection of the two, the both item. And again, the both item is your n, and your n will always be your numerator. For a conditional probability, your n will always be your numerator. You need to identify what is the denominator, okay? And the denominator is the item followed by the word given. So question with this particular problem, ladies and gentlemen. Now, if you don't have a question, they changing the script on you guys. And again, and that's what Alex is. Alex like to challenge you guys, right? And sometimes you're like, I don't want to be challenged, right? Just can't. But again, Alex like to challenge you guys, and look at this thing here. B, we see it, right? B, very easy to spot. We see the word given. We know that this is a conditional probability. But A, if you read A backward, forward, read it again, read it extra time, you say there's no word given up there, Mr. Tran. How do I know it's a conditional probability, right? So again, among the California adults, what is the probability that a random chosen internet user is a college graduate? And you read it and reread it and reread it. You're like, there is no word given there. But ladies and gentlemen, is a conditional probability. It's a conditional probability in the way that they ask you is basically, what is the probability of college student given that they are using the internet? You have to, one thing is, this item, you have to know that we are choosing the item, and the way that they set up, the way that they write it this way, this is the conditional. The condition that we have is the internet. So we want to choose a college student given that they are an internet user. So I don't really know how to explain this wording. For me, like I say, if it's clear at day, if they give you the word given, but this way, the way that they structure is basically is the same concept as they find the probability that is a college graduate given that that person using the internet or choosing the internet. Okay. But before we dissect A and B, let's take a look at what they give us, right? Let's take a look at what they give us here. So first of all, they give us 26. What is this 26%? That's what you need to ask yourself. Well, we know that 26% is the college graduate, right? So now we know that that 26% is a college graduate. And now 33%, what is the 33%? Well, the 33% is the internet user, right? And then they say 20%. What is this 20%? Well, 20% is both. So if you see, it's very consistently the same as before. It's just that the question is changing, right? So we know that again, 26%, that's your college graduate. The 31%, which is your internet user. And the 20% is the college graduate and also using the internet or internet user, right? So everybody see where the information they give us, how to dissect or what this information that they give us here. And once you have this item, again, part B, hopefully it's easy. Part A, like I mentioned, this is what they ask you. This is what they ask you is, you know, what is the probability that a random choosing internet user, meaning again, the condition that you are asking is they need to use the internet. That's the condition. The condition is the internet user. Once you extract out the internet user, of those internet user, how many of them are college graduate, right? So again, the probability, what is the probability at random choosing internet? So the description, the condition have to met is they have to be an internet user. Given that, you know, so it's the same idea that find the probability of a college graduate given that that person is an internet user. I don't know if you can see the connection between the two. You know, so we have to exclude, not exclude, but well, kind of exclude, right? We have to extract this group of people out. We just looking at this group of people, we choosing the internet user. And of those internet user, how many of them are college graduate? So again, if you can construct this item to this way, you can see that this is the given item, or in terms of the internet is your new denominator. And again, all we're doing is we put in the n over the internet, right? What is my n? My n is 0.20 over the internet, which is 0.3. So again, the answer will be 0.65. This item here for B is easy. Anything after the word given is your new denominator. So follow the word given is the college student. So the college student is here, the internet. So again, my denominator is the college student. And this is what I have is 0.20 divided by 0.26. Question right here, ladies and gentlemen. And I saw one thing is, you know, sometimes you try to look for consistency. And that's one thing about math is you try to look for consistency. One thing I noticed is if they give you this item, right here, if they give you this item, the other one is just the reciprocal, not the reciprocal, but just to flip the other two. So if you can identify one, the other one with basically the backward of the two. Let's try one more. I think I have one more. Let's try one more because I think this one here give you guys a lot of trouble. And again, I choose this one here that you don't see the word given. You don't see the word given at all. You see what is the probability I random select female student in civil engineer. What is the probability of random select civil engineer is a female? So again, you want to see, or this is the first group that you need to take out, which is the female student. Those are your conditional, those are the word given. And again, this is the first group that you need to take out, which is the civil engineer, not civil engineer. So again, before we do all that, let's take a look at what information they give us, right? Do you agree that we have 55 is a female student? So the probability of female is 55. We know that 19, right? 19 of them are civil engineer. 19 or civil engineer can be male, can be female. Civil engineer, 19%, right? And then furthermore, what is more, they give us both. The female who is in the engineer major, right? So again, this is what we have is in both, which is 8%, which is 0.8. So looking at all, the first problem, the second problem, and this problem here, hopefully you guys see that the information they give you, are very identical, right? The information they give you is they give you the individual, and the combination of the two, or the intersection of the two. And now looking at this item here, what is our criteria, or what is the condition? The condition is they have to be a female student. So again, you have to somehow convert this item to be probability of civil engineer given that person is a female student, right? We select from what group? The group of female. What is the probability of a random selected female? Meaning those are my group. My group is I want to just choose the female student. Compare the female student among the female student. What is the probability of them, or what is the probability they are civil engineer? So again, in terms of this thing here, my condition is the female student. And again, if you can identify that, which is we know that the female will be my denominator. And again, 0.08, sorry, divide by 0.55, this will be my answer. My answer is 0.15. And similarly, if you, like I mentioned, if this is one, the other one, Alex will flip them around, meaning the probability of a female given that is a civil engineer. We want to compare the female among just the civil engineer, right? Meaning this right here, there's 15% of a civil engineer who is a female, okay? Within the civil engineer, there are within the female, there's only 15% of them are civil engineer. The rest is nursing, doctor, whatever major they're in. 15% of the female, based on this information, 15% of female is civil engineer. But now inside the civil engineer, what are the percentage of them are female, right? So this is what we have is, again, we have the combination on top, which is 0.08. And again, the civil engineer is 0.19. And if you divide them, you can see that based on this information, among the civil engineer, 42 of them are female. Because remember, think about this thing here. Civil engineer, you can be a male or female, right? Let's say that there are two groups. There are female and male in this civil engineer, right? And again, among the civil engineer, 42 of them are female, meaning 58 of them are male, right? But among the female, the percent of civil engineer is only 15%. Okay, so again, that's what they ask you is among the female, how many of them are civil engineer, which is 15%, and that's what the conditional probability is. Is some condition have to met, and then we need to find the percent of those conditions. And if you later on, if you do any research or any study, when you do the placebo effect or blinded study, something like that, you do a lot of this conditional probability. But question here, ladies and gentlemen, question of how to extract your information, how to extract the information they give you, and using that information to answer the question. And let's take a look at the next set. I think the hardest part is out. All of this thing here, this one here. This is the other one that some of you guys have problem. I think this is the last one that they're confused. Everything else I think is very straightforward. They say let A and B be two events. So we have event A, event B. Suppose that P of A is equal to 0.5 and P of B is equal to 0.05. They ask you find B of A or B if given, which is the condition, right? given condition probability, given that they are mutually exclusive. So if you remember what is mutually exclusive mean, again, this go back to our formula. Mutually exclusive meaning they have nothing in common. And if they have nothing in common, basically tell you that all you need to do is find the probability of A plus the probability of B. So if they tell you, if the condition is they are mutually exclusive, then all you need to do is this, ladies and gentlemen, take 0.05, that's your probability of A, plus 0.05 probability of B. If you add them together, that's what probability of A or B is. So part A, that's what you have. You take the 0.5 plus the 0.05 to give you 0.55. Okay, so that's the mutually exclusive is easy. Mutually exclusive, just take the two items, add them together, we're done, because they have nothing in common. Okay, now for the condition is a little bit, not condition, for a dependent is a little bit different. So dependent, what does dependent mean? So if you look at this thing here, they ask you to find the same thing. They actually find the or, right? They ask you A or B. And to do this thing here, the independent, go to the independent item. The independent item is basically the probability of A and B, which probability of A multiplied to probability of B. That's what independent mean, right? The probability of A and B, and in this case, probability of A and B, which is A multiplied by B. And if you take A multiplied by B, you have that. But what you just find, when you multiply the two together, you find the and portion. You find the multiplication, the independent criteria. They did not ask you, the question did not ask you, find the probability of A and B. The question asks you, find the probability of A or B, right? So we need to convert this, which is again the other formula of the or. The other formula of the or is when they are not mutually exclusive, which is we need to find the probability of A plus probability of B minus probability of A and B. So pretty much they want you to use in this formula here. And if you use in this formula, you plug in probability of A is 0.5, probability of B is 0.05, minus the probability of A and B, we just found that, which is 0.05. So again, this is what we have is probability of A or B if they are independent. Again, if they are independent, probability of A or B is this right here. If they are mutually exclusive, this is the probability. So again, if they are mutually exclusive, this is the probability. If they are independent, we need to subtract what they have in common. Okay, and independent is they just want to make you using this concept of the word and let's try another one similarly, right? Similarly, if you look at this thing here, we know that they give us some A. They give us A, probability of A. They give us probability of B. And again, the two things, they reverse it. They reverse the item. They ask you for independent. So independent, this is what we need to do. We need to do the whole criteria right here, right? We need to multiply the two together. For independent, we need to multiply probability of A times B. So I have 0.05 times 0.15. And if I multiply them, that is what I have. But I'm not done. Like I mentioned, they don't ask you for probability of A and B. They ask you for probability of A or B. And to find probability of A or B, if they are independent, we need to add the two and subtract what they have in common, which is the intersection of the two. And if you add the two and subtract what we have just found out, this is what we have in terms of the item A or B when they are independent. Let me ask you guys a question with this independent connects to the probability of A or B, right? They, again, one thing is they kind of, for this thing here, kind of, they bend the rule a bit and they force you to connect the two items together. But that's the idea is you multiply them and then subtract what they have, subtract from the addition of the two. Because mutually exclusive is very easy. Mutually exclusive, If the condition is mutually exclusive, all you need to do is straightforward, take the two items, you add them up, and you call it a day. You are done. Okay, so mutually exclusive, you take the two, you add them up, that's your answer. If it's independent, then you have to multiply them and then subtract what the addition is. Subtract from the mutually exclusive. All right, let's take a look at the next few problem. I think I will, this one here, you have to read the word very carefully, ladies and gentlemen. This thing here, you have to, they ask you to mark in what fit this description, right? If you read this thing here, they ask you for event A, a head on the first two top. So the head, which is, again, everybody see that the first two, this is a head, this is a head. And again, doesn't matter if the third one, I don't care about the third one. The description that I need, is the first two top have to be a head. So if the first is a tail, I don't care. The first is a head, then I have to look at the second one, which is, again, I don't care, right? I need to have the first head and the second head, which is this item. First head, second head, that's the item. I don't care about the third one because the description does not mention anything about the third one. Okay, so again, that's what they ask you to do is check in how many items fit the description. And that is how many items I have, which is 2 out of what is the total item, I have 8. And that's all they ask you to do for this problem is first check the outcome. What are the two outcomes here? The outcome for B, 2 or more head. Is this item have 2 or more H? No, right? There are only one H, so it's not fit the description. 2 or more H is right here. 2 or more, right? 2 or more, 2 or more. So everybody see, as long as they have 2 or more, that's where I need to put a check, or that's where I need to mark. If they have only one head, I don't care because it does not fit the description. Okay, so again, once you have that, which is in this case, you have 4 over 8. Yes, you can reduce them to 1/2. Yes, on top, you can reduce to 1/4. You can reduce it. I just type it this way. And I purposely type it on Alex and they accept it. So you don't have to reduce them. And now they ask you for a tail on the last thought or the second thought or both. So again, we need a tail on the last one or on the second one or both, meaning again, the tail on the second one is here, so we would choose it. Because of the word or, if you remember, the tail on the second one, we choose it, or the tail on the last one, we choose it. The tail on the last one, we choose it. Again, this one is a head on the second one and a head on the last one, and this is a head on the second, head on the last. So again, we only need the back end of this thing here to be a tail, right? We need a tail on the last one or on the second one, or if it's both, it's fine. So it's either or, either one or the other or both. So in this case, everybody see that I have 6 of them. I have 6 of them, and I have 6 of them, and then again, over 8. Okay. So again, this is the idea. If you look at this the first time, you probably say, oh, how to do it is just basically ask yourself, what is the description that they want? Make sure that you check the description they want, and then just put those all over. This is the other item. The other item we have is if we give you this art, we give you this item, and I told you guys that we went over the art a little bit different from what the problem give you. So if you go to this fair, you can see that this is the balloon that you throw the dot at, and if it's pop, you win the prize, right? You have a small, medium, large, and extra large. So they ask you find the art against. Remember, the art against is what you don't have over what you have. Okay, find the art against Armand, win a medium stop animal. So how many item is not medium? So do you agree that we have 1 item, 2 item, 3 item, 4 item, 5, 6, 7? We have 7 item that is not medium. So this is all you do is, again, to find the odd is we looking for what item we have that is not the item, which is what is not medium. We have 7 items that is not medium, over how many medium do I have? So odd against is what we do not have over what we have. So 7/5. The reciprocal of this thing here, is odd in favor. Odd in favor is what we're looking for, what we have over what we don't have. So how many medium we have? We have 5 medium over the 7 that is not medium. So remember, the odd is not the probability. The odd is what we're looking for over odd in favor is what we have, what fit the description, over the item does not fit the description. The odd against is what does not fit the description over the item fit the description. There are 7 items against the 3 items I have, or there are 5 against the 5 items I have, right? And there are 5 items I have over the 7. Okay, so that's what we in your homework. There's the camera and all those stuff. Just ask yourself, the ring, the camera, and something else. Just ask yourself what fit the description over the item is not fit the description for odd in favor, and odd against is the item does not fit the description over the description. So here come, I think this is bear with me here. I think I have this one and one more. Find Frank entered a raffle to win a movie ticket. The probability of winning the movie ticket is 9/16. The probability. Now they say, if they give you this probability, how can you find the odd? Okay, so if they give you the probability, this is what you need to ask yourself is, do you agree that the probability of winning, that's what they give us, the probability of winning the movie ticket is 9/16. Meaning there are 9 winning tickets out of the total 16 tickets. That's the probability, right? What we have over the total. So do you agree that if we have 9 winning tickets, I can take 16, which is the total, minus 9 to give me that the remainder is the 7 losing ticket. There are 7 tickets that is a losing ticket, right? Meaning it does not fit the description of winning. So again, I have the total, right? The probability is 9 over the total. 9 is what we have, the winning ticket over the total. So in this case, to find the odd in favor, the odd in favor is you have 9 winning ticket to the 7 losing ticket. Okay, that's the idea of this thing here is, again, they give you the probability, you need to convert to the odd, and to find the probability to convert to the odd is, again, take the total minus what you have, and then again, the odd in favor is what you have, which is 9 over the remaining. Okay, and now how do you convert back if they give you the odd against? If you remember, if you look at the lecture we have earlier, the odd against is B over A. That's what the formula tell you. And to find the probability from the odd is basically A over A plus B. So if they give you the odd and they ask you to find the probability, all you do is A over A plus B. And this is what you do is, again, the odd against is B over A. So what is my B? My B is 11, my A is 7. So to find the probability, all I need to do is put 7 over the addition of the 2. So this thing here, right? How do I find this probability? I have A, which is the 9, over 7 plus 9, which is 16 that I have up here. But again, this item right here, we have 7 over 18. So if they give you the odd, you have to ask yourself, if they give you the odd in favor, it will be A over B. But in this case, they give you the odd against, so it will be B over A. Okay, so looking at this thing here, question with this item in terms of the odd in favor, or how to convert the odd to probability, or how to convert the probability back to the odd. Let me skip this one here. This one is the same as before. Let me do one more. No, let me skip this one. let me do this one here. This one here is not hard. It's just that, you know, they give you this item here for the Venn diagram. So let me cover this thing here, and then I'll let you guys go. If you look at this thing here, we know that the total, there are 10 students. And if you count the name, there are 10 names in this Venn diagram. Dancing and Spanish are not the name of the student. Those are your set A and set B, right? So the total are 10. And again, set A is dancing. There are 5 students: Linda, Donna, Harry, Kamal, Maria. And Spanish, which is your set B, you have 6 students, right? Kamal, Mary, Adu, Amy, Tammy, Michael. So they ask you, what is the probability of A? What is the probability of you select a student and that student is a dancer, right? In the dancing class or dancing club. So looking at this thing here, to find the probability, everybody see that we have the dancer, which is 5, over the total, which is 10. Again, what are we looking for? We're looking for the item in my A circle. And my A circle, this is the people in my A circle. I have 5 people out of the total of 10, which is 1/2, right? Simplify your fraction, which is 1/2, or single fraction. The probability of B, do you agree that the probability of B, I have 6 students in my B circle. I have 6 students in my B circle out of 10, which is, that is the probability of B. And what is the probability of A and B? If you remember A and B, which is, this is the item A and B, the A and B, I have 2. 2 students is in my A and B over 10. Now, what about probability of A or B? If you remember, A or B is probability of A plus probability of B minus probability of A and B. So if you look at this item, because they do have something in common, we need to take this item here. A or B is basically, as long as you're in the A circle, in the B circle, that's what we have. So we know that this is in my A circle or in my dancing. This is in my B. So any of this thing here, which is I have 9 students over 10 total. And if you plug into the formula, again, the purpose of this problem is they tell you that A or B, if you look at the Venn diagram, is the same as this formula here. 5 over 9, that's your probability of A, plus 6 over 10, that's your probability of B, minus 2 over 10, that's your probability of A and B. If you add them up and subtract them, you have the same answer as this item. So what does that mean? That means the probability of A or B is equal to this formula. That's what they ask you to do in this item here. So probability of A or B is equal to this formula that you add the two and subtract the item you have there. Okay. So one item or one thing we have, or this is what they ask you to do, is you look at the Venn diagram and you know, identify what set we have. I am over the time.